Hello everyone. In the last video, you learned what is a threaded binary tree. So last time we discussed a sample binary tree and a threaded binary tree. Threaded binary tree is a special kind of binary tree where null entries of left and right subtree are replaced by a special pointer called as a threads. These threads are normally denoted by a dotted lines. And this is a threaded binary tree based on the in-order traversal. So it is also called as an in-order threaded binary tree. Now we go ahead with the types of threaded binary tree. There are two types of threaded binary tree: single threaded or double threaded. Single threaded means one-way threading, where null entries, the right pointer is made to point to the in-ordered successor. That is, only the null entries of right pointers are updated, or it is pointing to the in-ordered successor. Whereas in double-threaded binary tree, both left and right null pointers are point to the in-order predecessor and in-ordered successor respectively. It helps to traverse the tree in the reverse and the post-order way. Let us see the example of simple threaded binary tree. So here are the null entries at the node 1. Only the right entry is pointing to the in-order successor. So the right pointer of 1 is pointing to the in-ordered successor, that is 3. The 5 is pointing to the 6. 7 is pointing to 8. 9 is pointing to 11. This is an example of single threaded binary tree. Now the second is a double threaded. Means null entries of left and right is pointing to the in-order predecessor and successor respectively. So how you can show it in the same binary tree? Now for this one, the right is pointing to the in-ordered successor and the left is pointing to the in-order predecessor. So the left of 5 is pointing to the predecessor, that is 3. Similarly, the left of 7 is pointing to the predecessor, in-order predecessor, that is 6. And for 9, it is pointing to 8 and 13 is pointing to 11. So this is the example of single threaded tree and double threaded tree. Let us see the node structure. The node structure of binary tree is data, information part, left address of left child, address of right child. But when you are defining a threaded binary tree, it contains one more field, that is R thread, if it is a single threaded, one-way threading. In one-way threading, if R thread value is 0, then there is a thread. If this field contains 1, means there is no thread and it is a normal node, where the left is pointing to the left child, right is pointing to the right child. Now there is a node structure for double threaded binary tree, where there is L thread and R thread. Both are containing the bits either 0 or 1. 0 means there is a thread and 1 means it is not containing the thread pointer. Okay, so if R thread is 0, means what? The right is holding the address of the in-ordered successor if R thread is 0. If L thread is 0 means the left pointer is holding the address of in-order predecessor. Okay, so this is nothing but the node structure of the threaded binary tree. Now you can represent it in this way as a structure, threaded binary tree node, character data, node star left and right pointers which are pointing to the left child and right child. And there is one more field which is added in a threaded binary tree is the R thread. It is of integer type. So it contains either 0 value or 1 value. 0 means a thread. It contains a thread pointer. And if it is 1 means it's a normal node. Okay. So this is a single one-way threading and this is a structure of two-way threading, that is a left entry as well as right thread. Both threads are there, left thread as well as right thread. The rest of the thing is common. Now if you observe one thing, that in previous example, the D left is null because the D is the starting node in in-order successor. So there is a dangling pointers like for D and G. The G is the last node in the in-order traversal, whereas D is the first node. So there is no predecessor for D and there is no successor for G. So these two pointers dangles. So what you have to do is you have to add one head node which points this threads. Okay, so there is a head node. This 1 it signifies it's a normal node, doesn't contain a thread address. Then this head node points to the root node, that is A. This 1 and this 1 means the left and right pointers are holding the left child and right child. Then the B is holding the left child because L thread is 1 and it is 0 means the right link is holding the address of in-order successor. So it is pointing back. So it climbs up. Similarly, for the D, there is L thread and R thread. Both are 0. Means both are containing the address of predecessor, in-order predecessor and in-order successor. So here left thread is contain the address of in-order predecessor and right thread is pointing to the address of in-order successor. So this 0 and 1 is nothing but the L thread and R thread values or L bit or R bit values. 1 means it is a normal, it holding the address of the normal child, whereas the 0 indicates there is a thread pointer. So this is a threaded binary tree with a head node. Now, this threaded binary tree is useful for traversing. You can traverse the tree without using a stack. So, in the next video, we'll see the traversal of a threaded binary tree. Thank you.